Hello and welcome back to the channel, and in today's video I'm going to show you how to recreate Donkey Kong in Godot 4. We have some cool features working here like ladders, jumping above the barrels falling down, and of course we can get to a princess and win the game, and we can die. So that's all that we're going to be implementing. Again, just to remind you, this is not the full feature complete game. This is just a blueprint for you that you can work and extend further. So let's get to coding. So let's start by setting up our project. I'm gonna open Godot Project Manager and I'm gonna create new project. Find a proper place for it. I'm going to create a new folder called this Donkey Kong tutorial. I will select current forward. The renderer is set to forward. Version control metadata is git. Let's create and edit. Okay. I'm going to start by bringing in all the assets that we need. So create new folder, assets, and you can find those in the repository. Let's bring them in. So open a file manager and let me click on everything that we need. These are mostly sprites. I won't be doing sounds for that tutorial. If you would like to know how to add sound, this should be available in my other tutorials. Okay, so let's very quickly go through what we have here. We have the barrel, Donkey Kong, the hammer, part of a ladder, Mario sprites that we need, platform, princess, we have one font, and then whole screen. The next thing that I would like to do is go to project settings, find the clear, to find default clear color, make it all black. Next thing is I would probably like to go and set up our input map for the movement. So go to project settings, input map, and let's start adding action, left, right, up, jump, and down. And let's add A, D, W, a jump is space, and down is S. Perfect. I believe that's all for now. I will also add a camera. Well, actually, let's start by creating a main node. So let's start with empty node. I typically call this main. Let's save it, create new folder. I'm gonna call one scripts for scripts, and then second scenes for scenes, and let's save main in scene. Perfect. And let's add a camera, and basically you can see that this is rectangular. I would like it to be in a different dimension, so what I have to go is to go project, general, and then find, I believe this is viewport, window, yes. And let's see, what do we need here? So let's make it 1000 by 1000 to make it square. And then also let's see, stretch can be disabled for that one. Cool. And now we have to re-add the camera, so it is being added with a new viewport. Now, as you can see, it is square. And if we try to run it, we have to select current scene to be the main scene, and we have nothing, but we have everything set up for our project. And in the next section, we will start working on our platforms. So I will see you there. Bye. Okay, let's start working on the elements of our level. One thing that we can do to help ourselves a little bit is to add a sprite 2D, and then in assets you can find an asset called screen. It should be screen, of course, and you can bring it in and actually use it a little bit as a reference outside of your camera bounds. So one thing that we can definitely work on are the platforms. So let's start and add a new scene. This is going to be rigid body 2D. Let's add a sprite to it. And this is of course going to be the platform. And we're going to name that platform. And let's start by changing the texture filter to nearest, and we can save that. Let's see, what else do we need? I'm gonna assume we need to change the color, so we can go to canvas item and then visibility and then modulate and make it dark pink. Okay, so we have color properly set up. Then what we should also do is enable the region, because the sprite here is a little bit too short for one segment, but we can extend it easily. So let's enable the region and let's provide some values here. And this is -0.5, 0, 24, and the height is 8.1. Okay. And then for the texture, we need to enable repeat. And now we just repeat that texture and our platform is longer. Then we can add the collision shape. So let's make it match our sprite. And this is easy. And then we will need some settings on a rigid body itself, because our platform is like the static obstacle on which our Mario can step. So we'll freeze it and we'll lock the rotation. So now this is like a floor. Okay, it's not like dynamic rigid body like a moving car. Okay, cool. And then what we also need is to add a simple script that we will use later. So let's go to scripts. Okay, let's delete all of that and let's use paint to let me show you why doing the script. So basically there are parts of our level where the platforms are connected by a ladder, right? And our hero must be able to go up the ladder and then down the ladder. And to avoid the collision between the hero, right, our Mario, and the platform, so that he can go up and down, we have to be able to disable and enable the collision on a given platform. So if he's going up, we don't want him to be stuck at the platform because he can move through it. But so we need to disable and enable the collision. Naturally, if he's standing right, if he's standing right here, right, he should be able to collide with the platform because this is like a solid floor. But we have to disable the collision for him to go up and down on the ladder through the platform. So to do that, we'll write a simple script. Let's add a class name platform. We'll get the reference to collision shape. We'll export a very simple variable that will be controlling whether a given platform can be disabled. And by default, it is the false. And then we'll write two simple functions: disable collision, and if it cannot be disabled, we'll just return and do nothing. Else, if it can be disabled, we'll set disabled to true. And we'll do the same with the enable collision. If it cannot be disabled, return. Else, set the disabled to false. Okay, and that's pretty much everything that we need for our platform. We can easily add it now. One thing that we will have to do though is change the scale with 4, and actually probably what we should do is to, because this feels oddly small. So what we can do is to simply go to platform, go to transform, and on the sprite, not on the platform, on the sprite, change the scale to 4, and then we will make it match. Now it should be all right. Yeah, now it seems correct. And basically this is going to be one of our building blocks for our level. The second one that we need to build our level, take a look, is of course the ladder. So in the next section we will handle how to dynamically set the height of the ladder, because you can see that they're different height, and we'd like to have some kind of easy way to control the height of the ladder. We'll do that in the next section. Okay, so for this section we will create the ladder. Let's go to scene, new scene. We'll use area 2D as a root scene. Let's bring in the sprite, and this is the ladder. Of course, what we have to do is set the filtering to nearest. Let's save it. Let's rename it first. Ladder. Let's save it. Let's check that. We will have to also use region here because we'd like to have it on repeat. So let's set it to enabled, and then 8 and 8. Now with the region properly set up, right, we can basically add our collision shape. But what we won't do is we won't define the shape itself, right? So here you will have that exclamation mark because this is going to be empty, as we will have to basically do it by hand to make it dynamic. So let's start by attaching new script. Let's go to scripts and let's open and create, and let's start coding. So I'm going to need a constant here, and this is going to be base region size, because we know that like one section of our ladder is 8, because if you can take a look at here, to make our ladder higher, we will repeat the same region, and we know that this is 8 because we set it up like here. Okay, then we'll define some stuff that we can use to steer our ladder. It's going to be length. I'm going to set it to 2. We'll also define the information about whether the barrel can come down this ladder. Go down, and we'll set it to false. We'll also set the random chance for our barrel to go down. So basically, if the ladder can go down this ladder, it doesn't mean it will always do, just to add a little bit of randomness to our game, but it can go down with like 50% chance. Then also on our ladder, we'll have to add a little bit of collision shape on top for our player to actually be able to go down and go up through the platform, right? So going back to our paint, if our ladder is gonna be this high, our collision shape, right, will be very thin but a little bit bigger so that we can detect the feet of our player, right, so that he can go beyond the ladder and into the platform. So this is going to be export bar ladder top length. This is going to be float. And then in our ready function, we can get rid of that. We'll code our dynamic collision shape. So, oh, we need some references. We need the reference to sprite2d and to the collision shape. And what I'm doing here is I'm dragging and holding control, letting go, and it's gonna create the reference for me. So sprite2d region rank is going to be rect2 0 base region size times length base region size times length. So what we're also going to do here, what we're going float. What we're doing here is we're dynamically also creating not only the collision shape but also the region, right? So if I'm going to go to main, and now I'm going to create a ladder here. It's like right here. And I believe this is too small. So sorry for that, I got disturbed by a call. But back to the matter at hand, we can go to a ladder, and then here in the root node, we can go to transform and set the scale to 4. That should help. And now I can go to length and set it to 1 and run it, and you will see that something is missing. Let me... Okay, it looks like the middle part is not rendering. And this is because we have to go to sprite and check the enabled texture repeat set to enabled. And now we have our ladder, but what is more important is that I can already work on its length by a simple variable and change how long it is. But of course we have to add more stuff to it. So to dynamically change the collision shape, go with the collision shape and set to rectangle shape to the new, and this is a constructor for a function, and we have to set size. So shape set size, this is going to be vector 2. It is going to be very thin, so 0.025, and then length times base region size plus ladder top length. And we can also say collision. We have to position it correctly on the y-axis, so collision shape y is base region size times length -1, or you can say that collision shape y position y is equal to ladder top length. Okay, and then sorry, collision shape 2D. So, oh, we don't need this. We don't need this really. And yeah, basically that should be it. If you go to debug and set visible collision shapes to true, and we run it, you can see it. So this is the collision shape of our ladder. So this is where our player can go and climb up the ladder. So he will be able to go through the platform. And with that basic two components for our lever build, we can now build the whole level. So in the next video that will be sped up, you will see me just building the level, placing everything in its right place. You can pause it to see where I'm placing, but basically I'm just trying as much as I can to recreate the what we know from the image. And also the other thing that you can use as a reference, if you search for what is it, I believe, yeah, if you go to FreeConk and choose new game, you will see, let me mute this. You will see how the level is built and what I'm using as a reference to build the level, right? So yeah, in the next section I will build the whole level for our game. So see you. So in this section we will try to build our level. I will speed up the video, but pay special awareness to how I am grouping the nodes all together and how I'm placing them. And you don't have to construct the very same level with the very same platforms and ladders as I do. I will basically try to put them around as I see fit, maybe not in some kind of the very best or very efficient way, but this should be close enough to what we've seen on the image or in the game itself. So let's get to work. And I can see that's something wrong with our ladder. I should be able to set the length to float. So let's add that type here, and that should allow us to change this property to 2.2 and a 0.5. Perfect. Let's see how this looks. Right, so I can see that I have to bring them up a little bit. I'm basically eyeballing all of that when it comes to placing the ladders. Okay, that's good enough. As you can see, I'm placing them so that they're creating this type of stairs, kind of, that our wonderful hero will have to traverse. Okay, so this is our level. There are a few things to fix actually, like each of our ladder should have their tip above the next platform. So for example, here, 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 well, maybe not here, but also here, here, and here should move or extend our ladders. So let's grab that, set this to 1.5 and bring this up. Still too low. So maybe here. Good. Next is this one. This should be 3.5 in that case. Yes, now it's correct. This is good. This is too low. So let's make it 1.5. Also move it up a bit. This is too low. So make it 3. And move it up a bit. Good. This is definitely too low. Let's make it 2.5 and move it up. Oh. And maybe move it to the side. I'm just eyeballing all of that. This should be higher. Still higher. Okay, now the tip is above the platform, and also here it should be 2.5 or even more, 2.75. Now it's above, perfect. We also need the platforms and the ladders for the princess platform. So let's do another node called ladders 6. Control Shift A, and we need a ladder somewhere here, maybe even here, and then another one here and here. Let's bring that in. We're trying to avoid any gaps between platforms on the same level. Let's see, and then we need the final platforms. Control Shift A, and let's bring that in here, another one in here, and then one a little bit lower for the princess. See how it looks. This looks correct, but those two can be smaller. Make them 1.5. Well, yeah, okay, that's good enough. One thing though that we can do to make it look a little bit better is to make the ladders render behind the platforms. Right, so now they seem like they're cut off properly and are not overlapping the platforms, because the order of the nodes in the tree of the game matters. So this thing's gonna get rendered behind that. And to finish that off, we need two sprites. One for the Kong, and we can just put it here, bring it here, change the texture to nearest, and let's scale it actually like ×4. Okay, so here's our Kong. We will not animate him, and we need our sprite for princess, and we can do it here. Change the texture, change the transform to 4. If we place her here, this is where our hero have to get, and I'm gonna say this is close enough for me. Again, it doesn't have to be pixel perfect. You can use those simple building blocks to build your own level, but I'm gonna call this finished for our case, and in the next scenario we'll start working on in the next section, sorry, we'll start working on our hero. So let's get to it. Let's start working on our player. So I'm gonna create new scene, and I'm gonna find character body 2D. We will name it player, and we will get an animated sprite. And because we will not use animation player for that, we'll use animated sprite. It's kind of cool. It's really helpful for those 2D. We don't have any sprite frames, so nothing is getting displayed. So let's create new sprite frames, and we should go to we should click left and choose edit, and now we can start working on our wonderful Mario. So I'm gonna create new animation, call this one idle, and for the idle I believe this is Mario Run 1. Yes, and you can see, of course, this is all blurry, so we have to change it to nearest. So we'll use the first frame of the Mario Run 1 as an idle frame. We'll save the scene and we can work on the collision shape now. So collision shape 2D, new shape, make it roughly match the outline of our character. I believe this is fine. And what is good and kind of cool, if we add new script and we place it in the scripts folder, for the character body 2D, it's gonna get pre-generated with some simple code that would allow us to, we have to place it. We have to place our player here, and we should be able to move him out of the box, as you can see. So this is pretty cool. Of course, what we have to do is change the scale to make it match everything, and we can do that easily by selecting the player node, going to transform and setting that to 4. Now into the, we can see that he is bigger and we can place him here. And yes, I can see that he's moving and he's jumping, and what's more important, he's colliding with the platforms properly. Cool. So basically we have to write the script for the proper movement of our character. So let's go back to script and let's start coding. We will need a few things here. First, let's open the scene. We'll need the reference to the animated sprite to change the sprite, and we'll also need the reference to collision shape, probably for later. Let's see. Okay, we have the detection of the floor. Probably would like to change the animations, right? Properly. So let's go to animated sprite, edit, and the default we'll rename it to, can we rename it? Yes, rename it to run. And here we can just slap the needed sprites. So we will have Mario Run 1, and then we're reusing this. Then we have Mario Run 2, then we have Mario Run 1 again, and Mario Run 3. And if we play this, we see we have simple running animation, and let's change this to 12. So it seems like he's running faster. So yes, this is our running animation and we have to play it. So going back to the script, we can change the names of the actions here, because that should be jump, then there should be left and right. Okay. And then what we need to check is the velocity, right? So I can say if velocity x is not equal to 0, I can just say let's create this running animation name is equal to run. And I can say animate the sprite to the play run. Else animated sprite to the play, and we're gonna have here idle animation. Idle animation name is equal to idle. And this should set us up when it comes to, yeah. Okay, what we can see here is that, of course, we're not flipping it correctly, right? So this is kind of problem. But what we have here is direction, right? So we will also store current direction here. And we'll set this to 1, meaning right, and -1 is left. And here, if direction, we set the velocity, this is cool. And then if direction is not equal to current direction, we'll set the current direction to be direction. And then if direction is greater than 0, we'll say animate sprite 2D, flip horizontally is equal to false, else animate sprite 2D if its direction is less than 0, we'll set the flip H to true. And that should cover, yes, the flipping. As you can see, this is working pretty neatly. The next thing that we should actually handle is for our Mario to be able to automatically go up and down the stairs. And to do that, we will need to set the layers for physics, because we will have different things and some should collide and some not. So we'll have player on the first, ladder on the second, barrel on the third, platform on the fourth, the hammer on the fifth, and the princess on the sixth. So these are all the collision layers that we need. Perfect. So let's assign proper layers to our entities. In case of our player, if we click on the character body 2D and go to the collision, he's existing on the player on the layer 1 because he is a player, and then he can collide with the ladder, with the barrel, with the platform. He should not collide with the hammer, and I will explain why, and then he should collide with the princess. So going back to a platform in the collision, let's see. That should be pretty straightforward because it exists on the layer platform and can collide with a player and with a barrel. And then for the ladder, it's the same, so it exists on the where is it? On the ladder, and then it can collide with the player and with a barrel. And that should set us up. Of course, that doesn't solve the issue of our player being stuck on the stairs. And basically, can we stop that? Yep, cool. So we have to add more code and actually detect the collision and tell player what to do. So here, after we move and slide, we can get the collision, for our player, and we will do this like this. We will write the custom function to handle that. So handle movement collision, and we have to write that function down. So what we have to do is actually access the last collision for our player. So we do var collision is equal to get last flight collision, and this is the function that we get from the character kinematic character body today. Sorry. Okay, so with that, we can cast it to kinematic collision, and if there is no collision, there is nothing to worry about, and we can simply return. But if there is, we have to search for the collider. Collision get collider. And we have to check what type of collision is this, because we can collide with a platform or a barrel or something else. So I can say if collider is platform, then what we need to do is actually, let me use a paint. We have to check the angle of our collision, because if this is a player and he's falling down and he falls down, right, and he falls down on our platform, this is all good, right? This is like normal behavior. But if this is our player and then he hits the stair like this during the running, we have to basically bump him up a little bit to allow him to move to the next set of stairs. And the angle of the collision is going to be different here, right? Because we know that this is going to be around 90 degrees, while this is going to be around 180 degrees, right? And using that information, we can detect the collision with the platform, with the stairs during running. So I can just write, degrees or collision degrees, and this is going to be round f rad to degrees, because collision has the get angle, but it returns radians. Get angle, and we check whether the collision degrees is 90, and if so, we can just boost up our player a little bit, let's say by 8. And let's see whether this actually works. Perfect. As you can see, our character can now go down and up the stairs. He can jump, so this is all good. And this basically sums up the basics of our movement. And in the next section, we will extend that so that he can climb the wall ladders and also is not getting stuck on the ceiling, right? Because in the original game, the collisions are only one way. Okay, so to extend the movement of our player, first thing is that he shouldn't collide with the ceiling when he jumps. That's not how it works in the original game. And to fix that, we can go to a platform, take a look at collision shape, and just set one-way collision. And if we have the visible collision shapes enabled, now we can see that he can properly jump and we fall down. That should not happen. Oh, we should set the one-way collision margin to 10 pixels. And now it should be all good. So this is how we can jump only one way. This is now only the floor, right? It's not also treated as a ceiling. This is perfect. Now it's time for us to actually be able to climb the ladders. So we'll start by going to a player, animated sprite, and we will add another animation. And I'm gonna call this climb. Oops. Climb. And this is actually going to be a single sprite animation. Where is it? Here, Mario Climb. What we could do actually is to go into any graphics editor and flip this basically horizontally, and then his right hand would go here, and then you would have a simple animation, but we can stick with just a single frame. That's fine. Okay, so to do that climbing mechanic, we have to go to our ladder script, and basically we need to connect to, let me see, let's go here. We have to connect to body entered and body exited. So let's connect those. On body entered, perfect, and go to ladder area 2D and connect to another signal, body exited. And first we'll check if whether what actually entered the ladder is a player. So if body is player, and also here is gonna be the same check, and we can cast the body to player because we know it is a player, and do start climbing. And this is the custom function that we'll write just in a second. And we also have to pass the current ladder position. And then here we'll go body, as player, stop climbing. Perfect. Let's go to a player and let's add both of those functions. So this is start climbing, which gets the ladder position X. And we will have to set some things here. One is going to be, we'll call this snap to ladder position X, and we'll do can climb, and we'll do is on ladder. Okay, so let me explain this, how it works in a game is that if that's the ladder, right, and its collision shape is, as you can tell, very thin, and then this is our player, if he as much, let me change the color, if he barely touches the ladder, it allows him to climb, but then as he starts climbing, he's moved and snapped into the middle of the ladder just for it to look nicer and be cleaner, right? So we run, then we detect the collision with the ladder collision shape, and then if we would like to start climbing, we'll snap the player to the middle of the ladder and allow him to climb at the top. I love Paint. This is the best tool to explain stuff for you while we're doing those wonderful games. And if it's on ladder, it's obviously false. So for the start climbing, what we will do is we will say snap ladder position is the ladder position X, and can climb is set to true. And then for the function that stops the climbing, stop climbing, we will say snap ladder position is equal to null, can climb is false, and is on ladder is false again. Okay, and basically what we have to do is to handle those states during our physics process. So let's go here and let's start checking stuff. We'll apply the gravity only if it's not on ladder. That's first change for the adding on the gravity. Then we handle jump, nothing interesting here. We allow to move sideways only if we're not on the ladder. So let's add this, right? What else? This is pretty much good. But then we'll write a custom function here, and we will say, oh, we have to handle the movement collision, right? Because, or do we? Let's see, we have to return the collision here. That is correct. And then we will just write a custom function to handle the climbing. So handle ladder climbing, we'll pass the collision, and we'll pass the delta. And if you don't know what delta is, I should probably record a video about that, but this is basically the amount of time that passed between the last call of the physics process and current call to it, because it's being continuously being called by the Godot engine, right? And this makes our movement independent of the time that passed between those calls, right? This is basically to make sure that the game runs pretty much the same when it comes to physics on a very, very fast computer and a very, very slow machine. Okay, we can write that function now. Climbing collision and delta. Okay. And we will start by saying if we can't climb, we'll simply return. Right, and then we will read the climb direction, input, get axis, down and up. We'll check whether the climbing direction is not equal to 0. Then we'll say, well, then he is on the ladder and the process of climbing has started. We can tell animated sprite 2D to play climb, and just to make it easier for us, we can cast it to animated sprite 2D. Cool. And next is we can adjust the X position of our player and snap him to snap to ladder position X. And then basically we have to check because this is not going to work as of yet, because what I could do is just say position Y minus equal to climb direction times climbing speed, we should define, times delta. So let's define the climbing speed. I'm going to set it to be a little lower than running speed. And let's see what we got. Could not find player. Yes, and this is because we don't have a class name here. Now it should work. Let's see. Oh, I changed the name of it. Why did I do that? No idea. Let's bring it back. Okay. So now if I go to a ladder, you can see I can climb, right? But I cannot go down, right? So we have the part of it working. At least I cannot go down when I'm off the ladder, right? Here I can climb down. Cool, right? But here it doesn't really work, right? Okay. And there's also one other thing that I would like to change, but we'll fix that soon. So basically, we have to give our player possibility to go down from the platform. And we have that property can be disabled to enable and disable all of the platforms that we need for that, right? So basically what we're searching for in our level are all the platforms from which our ladders go down. So there's going to be this and this and this, and maybe move it a little bit so it's not between platforms. This and this, 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 this. Let's move it a little bit. This and this, and I hope I did not forget about any. And then we have to detect what is currently underneath. So if we are here, we have to detect that platform and say, okay, can it be disabled? If so, then disable it and allow the Mario to go down. So going back to our code, we have to add a little bit of stuff when it comes to collision. And that should be here. So we pass the collision, and if we have the collision, we can just do something like this. If climb direction, we're going down, it's -1, and we have the collision, and collision is platform. We should check the collider actually. So collision get collider is platform. We can do platform, we'll do collision get collider as platform. Okay. Oh, it's the problem. Okay, and we check whether platform can be disabled. If so, we then have to say that, oh, we'll have to store the information about current platform. So let's create another var and call this platform underneath the player and set it to null for the start. And then here we will say platform underneath the player is equal to platform. and platform underneath the player, disable collision. And we have to store it so that we can re-enable it. And we'll re-enable it whenever our player goes up any ladder. So we can just say if climb direction is equal to 1 and we have stored the player platform underneath the player, we can say platform underneath the player, enable collision, enable collision, and set it to null. Let's see how this works. So I'm going here, I'm going up, and then I cannot go down. And oh, because this is definitely wrong. Okay, let's try this again. I'm here and I'm trying to go down. This is disabled, but one problem is that we're not let go of we're stuck, right? We're not getting let go of the ladder properly, but hey, we can go up and down. Okay, so then we also have to check for the stop climbing. Why is it not being called properly? And to fix the problem with being both on the ladder and on the floor, we have to add more code, of course. So let's go to our physics process, and then just beneath the handle ladder climbing, we have to do simple check. If we are on the ladder, but then we're also on the floor, we can set is on ladder to false, and we can say we will pay idle animation, which is idle, and we repeat it for the reason, and animated sprite to D, play, idle animation name. And that should be it when it comes to ladders. So let's try go. Yes, now we'll let go, and we can go up, we can go down. It seems like this isn't working for all the ladders. Oh, maybe I just didn't mark it as the one that should be disabled. Yes, this can be disabled. Now it should work. So we go up, we go down. And yeah, this is how we're climbing our ladders. Perfect. So with that done, we should be able to move to the next part of our game, which is spawning the barrels, right? Perfect. So let's handle the barrels and spawning of the barrels. Let's start by going to scene, new scene, and let's find our barrel, and we'll find the root by using rigid body. This makes sense. We'll use the physics to move it, and we need the representation, so we'll use the sprite 2D. Let's find it here. It should be a barrel. Perfect. Let's name it barrel. Save it. We will of course bump up the sprite when it comes to scale by 4. Texture, nearest. Perfect. And let's add the collision shape, and that's going to be circle. Let's make it roughly match what we need. Wonderful. Basically, this is all the setup, and we can start working on it. So let's add a new script. We'll move it to scripts, create, and for starters, let's get rid of everything. Let's add a class name, and name it barrel. We will have to define few consts. We'll do velocity breakpoint and set it to 300, and we'll need that for when our barrel is falling down. We will add a bump force Y set to 200, and then bump force X and set it to 100. Another const is fall down the ladder limit, and I will set it to 48. I will add fall down the ladder Y position, and I'm gonna get a reference to collision shape here. Then we'll need the speed, and we can actually export that. I'm gonna say velocity direction for the start is set to right, meaning 1. I will also define a few flags here. Should switch direction, and we'll set it to true. And I'm also going to set is going down the ladder. Perfect. So this is the basic setup, and to actually spawn our ladder, what we'll need in our main is a node, actually 2D node, and I will call this, basically we can go with a new scene, 2D scene, call this barrel spawner, save it, and I will also add a timer here and call this spawn timer. Okay, so this 2D node, which has no visual representations, is gonna be responsible for spawning our barrels between set periods of time. So first let's handle the timer, and we'll need just a little bit of code to handle that. Let's add a new script, move it to scripts. Let's use the underscore spawn timer, and this is the simple way to create a random timer, so it will trigger between some range. So to do that, we'll define mean time, and I'm going to set the float of 2. I will also do the max time, set it to 5. I'll do ready function, and here I'm going to create setup, and setup, and here basically we get the random timeout time. And we set the self wait time to be timeout time, and we start. Okay, and then in the barrel spawner we add another script, and we add it in the scripts. And what we need here is the reference to the barrel scene. Okay, we need the reference to our timer, and we need ready function. We can say spawn timer timeout connect on spawn timer timeout, and on spawn timer timeout we'll call just spawn barrel. And we also restart our timer, so spawn timer we call setup. And you don't see it in autocomplete because it's not casted, and you don't have it here because we don't have a class name. So it takes a little bit of additional code to make the autocomplete work with GDScript, as this is pretty much dynamic language, but you can make it work. Now if cast it, we have the setup function. And we'll just spawn the barrel. And add a child. And as you can see, what I'm trying to do is to just write the functions by just dividing the feature that I would like to achieve into smaller and smaller parts. I hope that you can see that in my code. I do not claim to be the best coder in the world because frankly, no one is. But now we can use this in our main. And we will have the barrel spawner. And this is a 2D node, not an empty node, because it has a place in our world. And I can place it maybe right around here between the legs of our Donkey Kong. And let's see what's going to happen. And we have, perfect, we have a barrel that is falling down. So this is cool, but I would like for it to have a proper collision set. So it does exist in the barrel layer. It can collide with the player, it should collide with the ladder to go down, and a platform. Okay, let's try this again. Okay, perfect, but it is not moving. So let's handle the movement of our barrel, right? So basically in physics process, let me see. What I would like for it is to spin. So probably I would like to add some velocity when it comes to angular velocity. So now it's going to rotate around its axis. And then let me think. Okay, simply say linear velocity x is equal to speed times velocity direction. And that should be enough for our barrel to move. Yes, but it's not going to behave properly. As you can see, it's not going to fall down the ladder, and it's not gonna change the direction of its movement. Okay, so basically what we have to detect is when it's falling down, right? Because if it's falling down or going down the ladder, it should switch the movement direction. Okay, so to make this work, we have to go back to our ladder and tell it what to do when it connects with the barrel. So in the ladder script, we can add a check for a barrel. And we have can barrel go down. And we also check for barrel goes down chance. And oops, this should be barrel. And so if you can go down this ladder, and if we say that, okay, we actually randomly check that it should go down, we then can call body as barrel, and we'll write a function fall down the ladder. Just to remind you, when you go and check the ladder here, it consists of two properties for the barrel. Can the barrel go down? and what's the chance for the barrel to go down. So for example, maybe for this barrel, the chance to go down is only 0.25, but for this is, I don't know, 75, 0.75. Okay, and this gives you a lot of more control when you're designing your level, right? It's good to export those properties to make your level more dynamic, right? So if our number to randomly chose rand f is greater than this, and the barrel can go down. Actually, for this first ladder and for testing, let me set this to 1. Or actually, this should be changed, because the higher the chance, the more the barrel should go down. So in our ladder, we will have to change that if it's lower, right? Because the higher this is, right, the more the chance should be. No, it was good. No, right? Because no, let me think. This is from 0 to 1, and the chance for this. No, that it should be like this, right? If this is lower, perfect. And we have to write fall down the ladder function now. So going back to our barrel, let's see. Fall down the ladder. Okay. And we set this to false in the start. And if we're already going down the ladder, simply return. Else, this is the code for us actually going down the ladder. We set the linear velocity x to 0, so we're not moving horizontally anymore. We fall down the ladder y position. We set this to position .y. We disable the collision mass value. Disable the collision with the platform, and we set is going down the ladder to true. Perfect. And then we can handle all of that in our physics process. Okay, first, if we're going down the ladder, we obtain our current position. From position.y, and we check if our current position.y minus fall down the ladder y position is greater than fall down the ladder limit. So how far should we fall down? How much should we fall down the ladder? This shouldn't be here, right? Because let me show you that in paint. So this is our barrel going down the ladder, right? And what will make it do, this is our barrel. What will make it do is we'll make it, go down the ladder just for some time, and then before it hits the platform, we'll re-enable its normal movement so it can go along. So we basically move as a rigid body here, then we take the direct control of our barrel to move it down the ladder, and then we allow the normal movement of rigid body to continue. So here we can say is going down the ladder, set to false, and we re-enable the collision. So set collision mask value to true. And we return as nothing else interests us. Okay. Then this is basically us going down the ladder. And then for the case when we're falling, and maybe let's see if that actually works. Let's see, it should go down and continue moving. Perfect. Then we have to also, let's change this to 0.5. Then we also have to handle the case when the barrel is just falling off the slope of the platform. So this should go, and this is going to go, and yeah, so that case, okay. We'll basically check the linear velocity of our barrel and stop it dead in the tracks and force it to go down, straight down. So if linear velocity is less than 200, and this is just a value of how to work correctly, we will move it normally. So if it's not falling too fast down, I mean, for example, between the stairs, just move along, right? But if it's falling down fast, we'll disable the movement on the x-axis. Linear velocity y. And then we say if linear velocity y is greater than velocity breakpoint, we will, and should we switch direction, we will switch it. So velocity direction is equal to multiply -1 to switch it. And should it switch direction right now? No. But then if it should not switch direction, and the linear velocity y is less than 0.1, we should switch direction. Okay, and this should allow us to switch direction whenever we go down the ladder or fall down the slope. Okay, as you can see, yeah, they're going down as the game intended. Of course, for now, they will collide and our Mario gets pushed back more and more by the barrels. But this is, of course, fine for now. But now we can switch direction when we go. And how does it work? Basically, what we do is we check the value of the linear velocity and make it switch direction. So if you can use the paint, right? So we have slope, right? We have a barrel. The barrel is falling down, and it was moving like this, but it is falling down fast. So we disable the linear velocity x, so it's not moving in that vector. By combining the y and x, it's just moving straight down because we set the velocity x to 0. And then the linear velocity grows and goes beyond the breaking point, which we set. You say, oh, you're falling down the slope and you should switch your direction about now. So we switch the direction to the second, to the next direction, right? From left to right or from right to left. And then this last part, this check with this minimum value, says, oh, you're just, let me just add another platform. And oh, you're just about to hit the ground. You're very close to hitting the ground. We can re-enable standard movement and make you move and make you remember that you should switch direction again when you're falling down again, right? So we basically, here we check whether you're moving really fast, and here we're checking whether you're about to hit the ground, right? Or you just hit the ground. But there's one little cool thing in the original game that they added, and I managed to recreate it. You see, after the barrel hits the ground, it does that little hop, right? Which is really, really cool. Okay, so what we can do here is we could apply impulse, which is vector2 velocity direction times bump force x and minus bump force y, and it's gonna do a little hop, a little bump. Let me show it to you. As soon as they respawn, okay, it will go down and boop, jump a little bit and do it again. So go down and again. So every time it falls down, boom, it jumps a little bit. This is a little cool addition. Perfect, and that basically handles the barrels for now. So I believe in the next section, what we could handle is Mario is being awarded points either for destroying the barrels with a hammer or jumping over them. So in the next section, we should handle jumping over the barrels. So how to handle our player jumping over the barrels? This is actually pretty cool, because what we have to do, let's use paint again, is whenever we have a barrel moving in that direction and we have our player jumping, over it, basically every single time we have our player jumping, we should detect where he's jumping over the barrel. And what we'll do is we'll use raycast 2D, which is the technique used to game to basically shoot ray to check for collision, or for example, whenever you're shooting, you're using raycast. Basically, this is like invisible, very fast, very long ray that detects what it hits. Very useful in games, as you can imagine. And we could write that in the code and handle all of it in the call, but thankfully Godot has a node that then can handle the case for that. It's raycast2D node, right? So if we go to our raycast2D node, what should it detect? It should detect the barrel, and we can change the target position, so how long it should be, to 30 pixels. Now if we run our game, you can see this is the raycast from our player. Pretty cool, right? And with that, we can handle our barrel collision. So here, if we're not on the floor, if not is on the floor, and this not is just sugar syntax for the exclamation mark. We can use both in GScript. We write a function check barrel collision. Perfect, let's write that function. Cool, let's see. What we need is a reference for our raycast2D. Place it here and we can cast it to raycast2D. And then we'll obtain the collider from the raycast, meaning what did you collide with? Hit collider. And we check if collider is barrel. If it is, we need the barrel ID to make sure we're not awarding the points 2 times for the very same barrel, because the process of I should have left that open. So again, platform, barrel, and our jumping friend, and the process of raycasting is continuous, right? So as we move and we jump, the raycast is gonna detect the very same barrel multiple times, and we're not interested in awarding the multiple points for jumping over the barrel. We just need the first check and first information of the collision. So we'll check the barrel ID, but in collider, get rid, and we need to remember what we collided previously with. So we can go to a tab and we can have last barrel ID and set it to null. And then here in our check barrel collision, what we can do is just say if last barrel ID is null, last barrel ID is barrel ID, and then we'll simply say we have a signal called award points that takes vector 2, takes position as vector 2. Let's say points position, just to not have the position name shadowed. Okay. And we will just change that so it's an assign and do award points emit. We'll do collider global position. Okay, and for now we're not going to use that. We will use that when we will be building UI, but let's just print award points and see how this works. So give me a barrel. I would like to jump over it. And we have award points triggered once. And it actually should trigger more times, and this is because we're not clearing the information about the last barrel ID. Yes, so we have to clear this. Basically, each time we do jump, we can reset the barrel ID to null, and now it should trigger for many barrels. Okay, award points once, award points twice. Now it's working properly. Cool. So this is how we can detect the barrels. Next thing that we have to see is actually the hammer functionality, because in the game there's a hammer, sometimes 2 hammers depending on the level, that our Mario can grab and start smashing the barrels. So this is going to be cool, I think. So yeah, let's do that in the next section. So in this section, we will implement the hammer feature, and let me tell you that this took a little bit for me to figure out. It's kind of tricky, but also when I figured it out, I was kind of proud of myself. So let's get going. We'll start by creating a new scene. It's gonna be area 2D as a root. We'll call this just hammer. Let's save this. Let's give this a sprite. And the sprite is obviously hammer. Let's go here. Let's check the transform. Can be set to 1. Texture nearest. And we need to add the collision shape. New shape, new rectangle shape. Let's grab it and make it match roughly to what we need. Okay, cool. And we'll need a simple script. Very easy. Go to scripts. And what we need is actually only the information about the hammer being fetched by a player. So I can go to node and say on body entered, connect, and we check whether this is the player. But first let me set the collision layer properly. It can collide with the player and it exists as a hammer. Perfect. So we know that body is a player, so and only player can collide with it. So I'm gonna say body as player, and we will create a function called hammer fetched, and we will UI free. So this is all the setup that we need. Let's go back to player and let's write that function at the bottom. And to test the collision, we can just for now print hammer fetched. And we have to place the hammer somewhere, right? So let's go to main. Here is our hero, and we can just go and instantiate the hammer here. Probably we need to change the transform to bump up the scale to 4. Let's place it here, for example. And let's see, something wrong with the debugger. Body entered, method not found. Let's see. Why? Oh, stupid mistake. Let's try that again. And we have the information about hammer fetch, and hammer is no longer here. Cool. Then we need to add few nodes to our player to make it work properly. So what I'm going to do is I'm going to add another sprite, and I'm going to call this hammer, and I'm going to also place it here. Let's see, we need to change it to be the nearest. Very important, we have to precisely set the transform for it, and it's 0 minus 11.25, so it's just above our player. Right, and we just let's make it idle. So now you can see that this space just of the top of our player, and the hammer itself is going to smash the barrels. So we need to detect whether the barrels are getting smashed, and to do that we will add another area 2D, and I'm going to call this hammer collision. And this is going to be a little bit different because it's not actually being used with the sprite, because we'll add the collision shape and we'd like to check for the barrels that are in front of us. So I'm just going to place the collision shape like right here. Okay, so this is just a visual representation of the feature. The actual collision of the barrel and the hammer when it's working will be detected here, because it makes no sense. The animation is gonna make it go up and down, and we're gonna do it completely via code to synchronize it with the hammer animations. But here is where the bar is gonna go through, and we'll stop them here. Alrighty then. So the next thing that we have to do is the animations for our hammer. So let me see. I'm gonna say we need idle idle hammer animation, and then run hammer animation. And for the idle hammer animation, we have, let me see, Mario hammer idle 1 and 2, and you can see him smashing it with the speed of 12 FPS. Okay, and then for the run, what we have is not that one. I believe we should use actually idle hammer for the run hammer animation. The first is Mario idle hammer, then we have Mario hammer 2, then again Mario hammer 1 and Mario hammer 4. And let's see how this looks. Well, it's good enough. Well, you have the PNG files and you can adjust this, because if we do Mario hammer running, let's check this real quick, 2, and then add this. Is this better? Oh, let's slow it down a little bit. No, it's not really better. I like the previous version more. Okay. So we have our animations for where we have a hammer and where we have no hammer. Okay, so let's start by filling out the hammer fetched. What we will make at the beginning is we'll get the references sprite and to the hammer collision. So bring this in and bring that in. Okay. And then in hammer, and we will also, at the very start, as you can see, we don't want that hammer displayed, right? So we will hide it. Okay, and then let's see, in the hammer fetched, we need to do a few things. We have to have a flag about whether we have a hammer. Okay, and we will set this to false because we don't have it at the start. But when we fetch it, we change it to true, so it has a hammer, and hammer should be visible. And also, we don't really care for that area collision. Okay. Turn on the mouse side. We don't care about this collision, right? If we don't have a hammer. And what we can do is we could go to this hammer collision area 2D and disable monitoring, right? So we don't care about the collisions with that area for now. But if we obtain the hammer, let's go here and cast this to area 2D. In that case, we say hammer collision monitoring. Now we care about it. Okay. Then there's another problem. Whenever Mario obtains a hammer, we don't want him to use it forever. So what we will do is we will add a timer, not a trimmer, but a timer. That lasts, for example, for 7 seconds. This is one shot, it's not repeating, and it doesn't have auto start. And we'll get a reference to it. And we'll call this hammer timer. And if we obtain it, we'll start our hammer timer. Okay, and we can also, in ready, we can connect to it. So hammer timer timeout connect on hammer timer timeout. So this basically disables the hammer mode, the hammer time. Oops. Okay. So what should happen in hammer timer? We basically have to reverse everything that hammer fetched it. So has hammer is false. Hammer visible false. Hammer collision monitoring is also false. Perfect. Okay. So what is the next step? The next step is to handle the animations probably, and this is going to be really interesting. So let's get to our physics process and start working on that. So first things first, here when we have running animation name, it's run when we don't have the hammer, else it's run hammer. If we don't have a hammer, it's idle, else this is idle hammer. Perfect. Then we need to do another check. It's another false also here. Else this is idle hammer. Perfect. Let's see whether this works. So we obtain the hammer and the idle animation works, but not the running animation. Let's go to animated sprite, and this is run hammer. Oh, I set it to run. Of course, I should use that variable here. Okay. Now let's obtain the hammer, and it does work, but of course our hammer is not moving, right? And the problem is we have to synchronize the movement of our hammer with the frames of our animation, and that part took me long enough to figure out, but after I figure out how to do it, it's pretty easy. So on the animated sprite 2D, we have the frame change signal, and we can connect to it with on sprite frames change callback. Let's write that function down. On write frames changed. And what we get here is ability to change the rotation and the position of our hammer. And what we need is we need the hammer starting point. So let's go here. Let's add hammer start position, because what we'll do is basically we will detect when the arm is down or arm is up, right? And we have a hammer right here. We have a hammer right here, right? And what we can do is we can rotate it around some point. So when the hand is down, right, the hammer is here. And we have to switch those positions every frame, but also take into account the direction that our player sprite is facing, right? So we'll rotate 90 degrees around some center point to make an illusion like the hammer is following our hand. Okay, so hammer start position is equal to hammer position. Yes, that should be enough. And then on frames changed. Well, if we don't have a hammer, or we are on the ladder, or we are dead, we'll add that later, should return. Then we should detect which frame are we running currently. So frame index can be taken from animated sprite to the frame. And then we should detect how the hammer should be rotated. So hammer rotation angle, and we don't need that here. And we will write a custom function here, get hammer rotation angle frame index, and let's write it down. Get hammer rotation angle by the frame index. If animated sprite 2D animation is set to idle hammer, then we know we're only using 2 frames. So return 90 degrees times sine current direction if frame index is equal to 0, else 0. So if the frame index is 0, then we should return 90 degrees rotation, but take into account whether we're facing left or the right. So that's going to be minus 90 or 90, right? And then we have to handle the case when the animation is a running animation. So run hammer, return 90 degrees time sine current direction if we are in the first or third animation frame, right? Because if we take a look at the frames, right, 1 or 3. Okay, and we could use Boolean operators like OR to detect first or the third frame, but actually we can do a nice trick and use array and use has function frame index. So this is a frame index 1 or 3, and we just are so smart that we can use array for that. Else return 0. So this nice neat trick. And we have the hammer rotation angle right now, and I can say hammer position is equal to hammer, and we need something called hammer rotation point, and this is going to be a const. So where is the origin of the rotation for our hammer? So I can say hammer rotation origin is a vector 2 of 0 and -3, and I just eyeballed it really. So let's go to here on sprite frames changed. I can say hammer rotation origin plus hammer start position minus hammer rotation origin rotated hammer rotation angle. And this by itself is going to work pretty neatly, but we also have to rotate the sprite itself. But you can see that it is getting synchronized. So I can also say hammer rotation degrees is equal to hammer rotation angle. And that should finalize our animation. Pretty cool, right? Okay, perfect. The next step is to actually destroy the hammer and the barrel, right? Yeah, so we can handle this in the next section because this one took long enough. Okay, colliding the hammer and the barrel is pretty simple. First, let's go to hammer collision and let's make it exist on the hammer layer and make it crush the barrel. So set the mask to 3, and then we just can get a note saying body entered, but remember to make sure that you have the hammer collision selected. And we can connect it to the sprite, and basically we'll award points emit with body global position and body UE3. So let's see where we are actually able to smack some barrels. Okay, and yeah, we can destroy the barrels right now. So that was quick and easy. Okay, so in this section we're gonna handle the displaying of the points for our player. So we'll award him points for jumping over the barrel or destroying the barrel, right? So maybe let's stop that. Let's go to main, and I'm gonna add an empty node and call this points manager. And we'll do everything by writing a script, but first we'll need another scene, very simple one, and that's gonna be other node, just a label, and I'm going to name this points label. Save this. Let's see. And we need a script and we need a timer here. I'm gonna add a timer, and 1 second is good and 1 shot is good. Yeah, and we will connect this timeout. Oh, we need a script. Let's add a point label script, because what we need is a script in our game to show whenever we get some points. So let's open. This is going to be extremely simple. We'll use that timer. We will make it auto start, and we'll use that timer to get rid of that label. So connect the timeout and just call QE QE free. Cool. That's all that we need. And then we can go to our main points manager, add a script. Let's name it properly, points manager. Okay, and now we can start working. So points manager have to have a reference to the label. So on ready var points label scene, we'll preload the points label. Cool. I'm also gonna set a value that will award Mario, the player, whenever he destroys a barrel or jumps over it. I'm gonna also define an offset here for our label. This is vector to 0 minus 2.5. And what we also need is a reference. Let's maybe add a class name. And what we also need is a reference to a player, and this is very simple. We can just drag and drop it. And we also need the overall points that we have in a game. So ready, player award points, and we can cast it to player. And we will say, oh sorry, it's very late here. I'm mighty tired. But we have to press on our points, and we get a position here from our signal from the player. Take a look at that signal. It is being called with vector 2. And we can use that information to place the label in our game world. So label, we need to instantiate it. We'll say add child, label position is equal to position that we get plus the offset on our points. We'll say label text, this is points increment, and we'll also say points plus equals points increment. Cool. One thing though that we'd like to change is go to points label, theme, and maybe theme overrides and fonts, and can drop the retro gaming font here and change the font size to be something like, I don't know, 16. And basically that's it. Let's see whether this is working. Let's try and jump over a barrel. And you have points and they disappear. Cool. What about destroying the barrel? Oh, it's... Oh, we don't change. This is the issue. As you can see, we don't change the collision shape direction here. Okay, so this is something we have to fix. Right, so here is where we detect the barrels, but if we go this way, we should move it here. Easy fix. Let's go to player. And let's see. We should have reference to a hammer collision. Right, and if we go to our physics process, where we change direction, we can say hammer collision position equal to vector2 and 0, and in this case we can say hammer collision position is equal to vector2 minus 10 0. And this does not seem to be correct. Let's see. This is the collision shape, and yeah, as you can see, that's the problem. The collision shape should be moved to 0, 0, and then hammer collision, so area 2D itself should be set to 10, right? So before we change that transform, which is relative to this transform, but we have to manipulate this transform as this is relative to our player. And now it is correct. Cool. So what's left for us to do is to detect the to add a simple UI and detect the collision with the princess for the player to win the game. So yeah, let's work on that UI in the next episode. Okay, we have two things left to do. One is UI, the second is the collision with the princess. Let's start by creating the UI. So go to new scene, choose other node, you'll use canvas layer, name it UI, save it, add a script, move the script to the scripts folder, UIGD, this is fine. Let's create and let's get to work on our UI. So I am going to start by adding the margin container and overriding the themes and setting its all margins to 8. Then at the top, I would like to have the information about the points and maybe a simple information about winning the game so that we know that we reached the princess. So let's add an HBox container. Let's add a label. Let's call this score. And let's add another one and call this win label. Okay. We have to place them properly, so let's start by saying this is points. Oops. Points is equal to 0. Theme overrides, fonts. Let's bring the retro gaming font. Perfect. And oh, this is that should not be here. Um, oops, that should be in the score label. So this team overrides fonts, retro gaming, perfect. And then this, let's see, we should go to container sizing, which is in layout, and set this to expand. Right. Let's see. Oops. Yeah, I think so. And then we should set it here and then here. Let's see, and we will write you have won. I would like it to be pushed right there. So let's see, we'll fill the space here. And also for the margin container itself, we have to make it expand. Okay, and then we can align stuff. So this should be aligned at the top, expanded here. It should be here, and this should be here. One problem that I see is that it's not taking enough space. So we're missing a property here. So let's see, this is horizontal alignment right, vertical top, and it should expand. Okay, now it's correct, and we can make it fill if we need, or shrink, and it's also fine. And we will hide it for the start. So this is one part of our UI. The second part of our UI we'll use for whenever we hit a barrel and would like to restart the game. So in our merging container, let's add a center container. Inside of it, let's add a panel. Go to layout, make the size 200 by 200. Change the theme, not the theme, sorry, the theme override styles. New style box flat, and now we can change the color. Let's make it evil pink. Then we need to add another child node at the hbox container here. Let's see, make it span across, and we will add a label, and we will add a button. This hbox, it should be vbox. Let's change the type, vbox container, and let's change the name here too. This is vbox container. Cool. Let's see. You lost. This is nice information. Set it to center, and we should also have the ability to center this one. Perfect. So do not expand, make it center. Then we can also call this restart button, restart. And then what do we need? We would like to change the fonts. Let's bring the retro gaming, and now this is correct. And here we will also like to bring the retro gaming. Let's drop it. Perfect. And we'll need to connect to all pressed. And here I can just call get 3 reload current scene. And then what else do we need? We need to hide this, and we need to hide the win label. Okay, so let's class name UI, and we need few references. One is for the score, one is for the win label, and one is for the center container. And we'll write show loose UI. And this is loose container, or sorry, center container. Show win UI, and this is win label show, and then set points to update the label text. So the score text points %d %points. Okay, cool. Whew. Now we have to connect it everywhere that we actually need. So for example, in the points manager, we first have to add this, and then we can get a reference to it. Perfect, let's maybe move it up. And here on our points, I can just say UI, and I can cast this to get the autocomplete. UI set points. Let's see whether this works. So you have 0 points, but if I were to jump over now, it is being updated properly. Cool. So this is the UI, but then what we have to do is to handle the case of our wonderful player dying. So let me think. We can go into handle movement collision and check whether the collider is player. I mean barrel. If collider is barrel and we are not dead, die. And we need to define the flag for this. And create the die function. So let's see. Now let's print die. And we will set the is that to true. And just to speed things up, I'm gonna move our Mario, our player, here to here. Okay. Die. Okay, perfect. Cool. Oh, but I saw something strange happening. No, this is fine. Okay. So for our die function, we will need die animation, and thankfully we have one prepared. Let's go to player, animated sprite. Let's do die. And this animation is going to be a little bit different. But let's get this. This is Mario Def 1, 2, 3, 4, 5. But the last one, I would like it to stay on the screen a little bit longer, so I can click it, take the frame duration and bump it to, for example, 6. Okay. Let's see, what do we have to do what else do we have to do when we die? We have to disable the gravity. We have to set the collision layer value so nothing else collides with us. We have to disable the processing of the input. And we have to play the animation. Play. Die. Okay, but there's one other thing I would like to do. I would like to display that piece of UI about when we're dead, but only when the animation finishes, right? So what I can do is go to animated sprite 2D to node, and here we have animation finish signal. I can connect to it, and I can check the currently played animation, or the one that just ended. If animated sprite 2D animation is equal to die, we'll get the reference to our UI by simply saying export var UI and just saying UI that show lose UI. Then in the main we have to find our player and pass the reference to the UI. Okay, I believe that's all. Or not. Okay, this is interesting. Let's see. Seems like the gravity was disabled, but this is called die. And why doesn't it play? Let's see. Oh, I know why. Yeah, because it's getting overridden by what we do in physics process. We can just say if is dead, let's return, and then probably we don't need to even do that. So let's try this again. Yeah, we play it. Cool. And it is looping, so it's not going to end. Let's go to sprite frames, edit, and disable looping by clicking on those arrows here. Lost, restart, cool. One other bug I can see is that this platform is not behaving correctly. Right, and we have to check why. So let's see. Can this be disabled? Probably that's not going to help. Oh, I think I know what might be the problem. This is simply just too far from each other, right? So let's move it up. Let's move that up. Let's see, we have then to change this to be 3.5 probably. Let's try this now. Yeah, now it's perfect. Okay. So now we die. And the last thing to do is to detect the collision with the princess. And this is actually pretty simple to do. Let's see. We can find our princess and we need to add the area to D here. So let's actually create new scene, area to D. Let's call this princess. Add pretty much the standard stuff. Add the sprite to D. Let's find the princess here. Okay, save this. Add a collision shape. Let's change the filtering. This and this. Let's add a simple script. Perfect. Get rid of everything. Export the reference to UI. Set the collision to proper layer. So this is a princess and it collides with the player. And let's get that signal body entered. Check if body is a player. If so, UI. Show when UI. And then going back to main, we can get rid of that node. Instantiate new princess. Change the transform, bump up the scale to 4. Place it when it should be. And let's see whether that works. So I'm Mario and I jump to a princess and it crashes because we didn't pass the reference. So going back to main, princess, and pass the UI reference here. But at least we know that the collision is working. And you have won. And this is it, my dear friends. I know that this is maybe a very simplified version of the Donkey Kong, but I believe that again, this is a good blueprint that you can use to add more to the game. Definitely build a better UI. I'm not really a UI guy when it comes to Godot, but probably I should look into it more. But we have that. We have the barrels, the jumping, right? We have the collision detection. We have the hammer working, which is great. And we have the ability to count our points. Cool. Thank you very much. I'm gonna figure out what's going to be the next game that I would like to recreate. I know that there are some suggestions in the comments and I really do love them, but first I have to get through my initial list. I also have other things planned for us, like I've got a few comments regarding whether I can help, so maybe opening a Discord will be a good idea. I will be putting that up for discussion. I also plan to do 3D games, and I also would like to record some videos about specific Godot nodes or features, or how to implement not maybe a whole game but some single feature that is repeating across games. So there's a lots of plans for me to record, but everything takes time, and I have a full-time job as a web developer, and I really have to figure out the time to prepare and record all of that. Anyway, thank you for that, and I'll see you in the next video. Goodbye.